It's awesome to be here with you today. I'll just say that one of the easiest ways that I like to learn, or one of the most common ways for me to learn, is just to ask lots of questions. So at any time through this, if you have like any questions or comments or ideas on what I'm saying or what I'm working through as examples, just raise your hand and I'll try to get to you, and feel free to ask anything you want with me about 3D design in 3D printing. Is that this is a new technology that allows you to take anything that's in your mind, absolutely anything, put it into a computer, and then with a press of a button you get to see it formed in real life. Yeah?
What's like your best 3D picture?
So we actually have 12 of these guys, the Athenians. And while they're kind of small, they don't break like ever, which means that I don't have to fix them like ever. So they are definitely my favorite 3D printer, and that's one of the things I always tell people is don't necessarily judge a printer by its size, because we can talk about this a little bit in 3D design, but you can always break a big design file into smaller parts, and they kind of can be designed to be like Lego, where they fit together and they snap together. And then you can print lots of little things at once. When you have 3D printers, you can print 30 parts at one time instead of just printing, one big part at a time. It may take a little longer doing that. So yeah, these printers are by far my favorite. And when Tamara emailed me a while back, I was like, get this printer, and that's what she got. So
and I listened.
you guys have a chance to play with it now. Yeah.
Is it possible to print food?
Yes. So I've got two sections of my talk. We're going to do a little bit of design first, and then we'll talk about different 3D printing technologies and how neat it is. But everything that I said earlier, chocolate and ice cream, those have both been 3D printed now. Actually, a good friend of mine made an ice cream 3D printer for a class project last year in college. So if you really like 3D printing, this is something you can go to school for full time and work on printers to print ice cream shapes. Yeah.
Is it edible ice cream?
Yeah. So it prints. You can make a snowman out of ice cream and then eat it, which is pretty neat. I could show you guys maybe a YouTube video of that later. But yeah.
Is it possible to print like ice sculptures, like print out of water or something, and then like freeze it?
Maybe that might be kind of difficult, but if you can print ice cream, you might be able to print ice. It would be kind of weird to get the water to freeze at a particular point as you're like laying it down, but maybe you could use like liquid nitrogen or something. You'd have to have something really, really cold to go from water to ice very fast, but we can talk about that in the 3D printing section. So have you guys designed much with QFI so far? Like what is the best thing you've designed so far? Let's do that. Yeah.
The dice.
Okay, dice. Yeah.
Well, this summer, Kyle made me retarded.
Oh, neat.
I printed it. I didn't design it.
Okay, cool. So maybe we'll start out by designing the targets or something similar with that, and we'll go from there. Yeah.
I haven't designed this for college. We printed a unicorn. Yeah. Did you make that?
Okay, let's ask this question. If you guys could design anything, what would you design?
Like, I'm super into cheeseburgers, so like a really big cheeseburger.
Oh, okay.
I like
Alright, that may be a good one to start out with, yeah.
a 3D printer that can print 3D print.
I don't know if I'll be able to do that in like 10 or 20 minutes, but that's a good idea, yeah.
I would design shoes.
Shoes, okay, one more.
I would design animals.
Animals. Okay, so how about we design a cheeseburger and a cat? Alright, so
Let's make them both together.
a cheeseburger cat. A cat dressed up as a cheeseburger.
Yeah.
Okay. So when I 3D design something or want to design something that may be complicated like a cat, there are a couple of different ways that you can look at 3D design. So one way may be, okay, let's take a cat and break it into simple shapes, like the cat's body may be a cylinder and its legs are also cylinders and its head could be like a cube or something like that. So I usually like to think about things maybe in two ways, is how can I construct this shape this complicated shape like a cheeseburger or a cat out of simpler shapes, or can I make a 2D sketch and then form that into a cat? So we'll look at both ways, and then yeah.
Just a reminder that the next thing we make with Cubify Invent will be some kind of like an avatar of yourself. So keep that in your mind as you watch what he does.
Yes.
Wait, I have a question.
Yeah, go for it.
Can we, so if, when we make the avatars, can mine be wearing a cheeseburger suit?
Yeah. The sky's the limit when it comes to avatars.
So, fortunately, Cubify is a little different from Tinkercad. Tinkercad is sort of more oriented towards taking those shapes and then making things out of them. So, like, for instance, in Cubify, you can just make a cylinder and connect more cylinders to it. This software is more like things that I use from a day-to-day basis, and things that, so like I worked at NASA 2 summers ago, and we designed robot parts for space robots. And Tinkercad, designing parts in Tinkercad for NASA, you wouldn't really be able to make those complicated space robot parts in Tinkercad because it's kind of like a simple software. This software is really similar to the software I use every day is called SolidWorks. It's like a $20,000 software that NASA and Georgia Tech uses, and Georgia Tech gives it to me for free, so that's nice that I get to use it all the time. But Tinkercad is actually really, really similar to that. So learning Tinkercad may one day...
Cubify Invent.
Oh, sorry.
That's right.
Cubify Invent. Learning Cubify Invent, one day you might get down the road and you might be at NASA and you pull up SolidWorks and you're like, oh, this is really similar to what I learned in 6th grade. So maybe the lessons you take here you can sort of use with other CAD softwares as well, because this is very similar to just about everything else on the market. Yeah. It's alright, if you remember, I'm going to start designing and then you can ask a question. Yeah.
So when you said the program costs, like, how many, $20,000?
Yeah.
So you were kind of like, it was kind of like, you brought somebody, the teacher was like, train one, get one, never mind.
If you remember, just let me know. Yeah.
So, like, you said you were going with space robots? What is that?
So, I guess a brief aside, I'll show you what I worked on. It's called the Multi-Mission Surface Exploration Vehicle. I call it the Space RV. This is a picture of what the final version will look like. The pictures of the version that I worked on are not public. But basically what this is designed for is for a team of astronauts, up to 4 astronauts, to live in this thing for about a month and a half. So it's meant to go to the moon or Mars, and they can live in it for a while and go exploring on the surface.
That's impressive.
And it's got beds and toilets and a kitchenette and TVs and stereos and little chairs.
How big is it? And how big is it made?
Oh yeah, so we have several prototypes already made. This is a good perspective in the inside. They actually have, this version is actually a simulator, so everything you see out the windows is a lot of high resolution displays. And this thing is on an air bed, which basically means that they can make it hover. So this bottom platform, they can hook air hoses up to and make it float. And when you move the stick on the inside of the cabin, it will move the whole module and the displays change with that. So it simulates being in a real environment. And I designed battery connectors for this. Yeah.
If they had like TVs in there, do they have cable?
No, but they do have like satellite. I don't think they get like direct TV, but they use them for communicating back and forth. And there's actually a lot of people at NASA who sit down and say, okay, we're going to be putting 4 people in this thing for about 2 months. How do we make sure they don't go crazy? And one of those answers may be, oh, well, we could give them Nickelodeon or Xbox One and play Halo or Destiny or Call of Duty. So who knows, there are a lot of people who are working on that at NASA, and if that's something you're interested in, giving astronauts TV, I'm sure there are people working on it.
I have 2 things.
Yeah.
One, when you, remember that picture of the lady? Was she like texting? She was all like, on moon, click, hashtag. And then second, if you like spray painted the thing, like red, and then put like a beige kind of, an orangey beige kind of thing around it. Wouldn't it kind of look like a hot dog?
Yeah.
Might look like the Oscar Mayer wiener burrito. Yeah.
What's
So
that?
you said that there are beds in there. How do you sleep when you're on the beach?
Yeah. So they have these big Velcro straps. They're like fancy sleeping bags, and you can.
In a sleeping bag, you floating?
Okay.
So on the moon there is a little bit of gravity. It's not as much as the Earth, but you can like strap yourself down and you stay in place. It's not extremely comfortable, but NASA actually invented memory foam, so their chairs and beds are actually very comfortable. I slept in it one night and it wasn't that bad at all.
So, wouldn't the astronauts be able to go to sleep just floating around? Because
They could, but they might run into things if they get moved
Yeah,
out.
they might get it.
Yeah, and you could get a concussion, so there are lots of weird things.
All right,
that
folks,
have to
you know
do.
what? Let's let Chad go
Yeah,
on
so-
with Cubify Invent, so hold your questions for a little bit. Let's go on to the next part.
So if we were designing a cat out of basic shapes, basically I would design from the ground up, and the first thing I would start with are its legs. So legs are fairly similar to like cylinders, so what we would do is make 4 circles and then make those into cylinders. And the easiest way to do that is just to start a sketch, which I think you guys have done before, right? You've all started sketches, and then we can make some circles. The neat thing about CAD is repetitive things it makes really easy. That's what computers should always be used for. If you're doing something on a computer and it seems hard or repetitive, you may be doing something wrong, so look for ways to sort of optimize. And the neat thing about most CAD software is, I haven't actually looked to see if this one will do that, but you can actually define all of your dimensions to make sure everything, you don't have to like drag and drop in very particular locations. You can actually tell it exactly where you want your part to be. So this cat, I want its legs to be a 1/4 of an inch apart, or a 1/2 inch apart actually, let's do that, from side to side, and then let's make it about 1 inch long. So we want to make the front 2 legs about 1/2 inch forward, and the back legs 1/2 inch back, so we have an inch long total. Yeah.
So you say that this is a CAD software?
Yeah.
What is that?
CAD is computer assisted design, or computer aided design. So it means instead of drawing it by hand, which is what they used to do, and a lot of people still do drawings by hand for dimensional stuff, but this means a computer is helping you with
Do you
it.
3D print that you draw?
So you can like scan it and then make it into a 3D or 2D design and then do that. So yeah, that's definitely possible as well. But to go on with this example, let's say we make our 4 legs. It's told me there that our circles are the same size. We'll make sure they're dimensioned the same way. So 0.25. And this is not the way that I would normally do this, but I'm just doing this to illustrate a point of how you could do it. If this is the way you think about it, then do this for sure. You can really do things either way, and then abstract from there or work down. The software that I use has a function that lets you mirror things, so like right now we'd be able to select those 2 circles, click the line, and then flip them over the
There
line.
should be a mirror.
Yeah, up there.
There's a mirror.
Up there.
So you guys
Oh, I
know
see it.
this one?
No, it's
above
like-
that.
Oh, yeah,
It's
right
on the
there.
very top.
I remember seeing it
It's the
earlier
green
this
one,
morning.
Green, it's on a green.
Green?
Yeah,
Oh,
right there.
Yeah, okay, cool. Yes, no, that's symmetric constraint.
Dang.
I know it's somewhere here because I saw it this morning.
There's a little
Right
question
there.
mark over there if you want to look at the question mark.
Isn't it? How much is this
That would be
software?
good. Yeah, how much is this?
It's about $50.
Wow.
So the thing you're seeing right now is basically, if you were to go from Cubify to SolidWorks, you would just basically, you would know what you're doing, but you would say, oh, where are all the buttons that I'm used to? And that's kind of the same thing that's happening now. But anyways, let's pretend like there's a mirror. There doesn't have to be, because I can do this without a mirror function. The nice thing is it's telling me where to put all of these and telling me where I get 1/4 inch diameter. We'll go ahead and constrain these, 0.5.
When you say constrain, you mean?
So constrain means to put something in a particular place that you can define and then keep it there. So what I'm doing right now is using the dimension tool to make sure everything is exactly where I want it to be. So again, I'm making sure that each of these are basically 1/4 inch from this line and 1/2 inch from this line. And now when we come out of the sketch, we can extrude, we can make these circles into cylinders by using the extrude function. Let's make our cat 1 inch tall.
So what?
And now we basically have 4 cylinders that can be used as legs. And as you can see, these don't really look that much like legs, because they're just cylinders.
Could you curve the edges?
So you can curve the edges, you can do lots of different things here. You could add like blocks on and then curve the shapes of the blocks to make it look like a knee. You can add a cylinder on the top to make like the cat's body, but this kind of illustrates what I was hoping to show you guys, is that putting basic shapes together like this may not be the easiest way to make a cat, because you're going to have to do a lot of work to make cylinders look like legs and cylinders look like faces and ears and things like that. Yeah.
So what makes your software like better than this one?
So it's a lot of this functionality is basically the same. The things that SolidWorks can do that are a little bit different than this software are you can like make parts that move with each other and you can simulate movement. You could also say, okay, I want to put water through this cat. How will the water flow through the cat and different materials? You can also tell it, okay, well, I want this leg to be made out of high-density polyethylene and the other leg to be made out of stainless steel. How much will this weigh? You know, crazy things like that. This software is basically just oriented to design. SolidWorks does design and engineering things, so you can do all sorts of crazy stuff. I basically use it for...
$20,000.
Yeah, so you kind of get what you pay for. When you're designing a car at General Motors or Ford or whoever, they want to know, okay, well, how will this engine move, or how much will it weigh, and that software lets you know those things, where this you're just designing something to be 3D printed. Yeah.
I have a year subscription to SolidWorks.
Oh, neat, yeah.
Similar to Georgia Tech camp.
Yeah, cool. Yeah, so you'll notice a lot of similarities in the interfaces between the two softwares. But so anyways, designing from basic shapes, sticking shapes together, you can make things like our 4 legs here, but it's kind of difficult. And what I'll show you guys now is if I were to design a cat with a cheeseburger around it, this is how I would do it. So we'll start a new invention. And what I'm going to do is make a 2-dimensional sketch, and then I'm going to turn that sketch into 3 dimensions by extruding it, and then we can add curves to make it look more like a cat. And what you'll end up with is something that looks more like a cat with less work, to make it look photorealistic, like a real cat that you could 3D print and freak someone out because it looked like a real cat. That would be very difficult, but for making like a simple trinket to show to your friends, like, hey, I 3D printed a cat, they would look at it and think, that actually looks like a cat. Other than, oh man, that looks like a bunch of tubes stuck together. So let's make something that looks a little more like a cat. And what I'm going to do here is just make another sketch again. And this kind of involves a little more artistic ability than sticking cubes together, but if you take your time while you're doing this, you can end up with something that looks really nice. I'm going to just pretend like I can draw quickly, but we'll see how it goes. So what I'm going to start out with is just imagine we're looking at a picture of a cat from the side, right? When you look at a picture, you don't necessarily see everything in 3 dimensions. So let's get a cat side view. Sure, drawing will work just fine. So basically, if you're looking at a cat from the side, you see something like this, right? So this is what we're going to want to draw. We'll make that into 3 dimensions, and then we'll add curves to it to make it look like an actual cat. But just about anything you can think of, like this lizard here, if you wanted to design a lizard, if you're looking at it in person, you know that it has depth, it has 3 dimensions, but if you're looking at it from the side, like on a picture, it has clear 2D lines that you can make a drawing of. So that's what we're going to do. I'm going to make something that looks hopefully kind of similar to this image here. We'll extrude it and then see what happens.
Can you name the cat cheeseburger hybrid fluffy?
Cheeseburger hybrid fluffy. So let's start with the legs. This is its paw here.
Oh, I used Sony Vegas Pro 9 once, and that's how you do things on it.
What is Sony Vegas Pro 9?
No, it's not a game. It's a program. I can use it to like cut out things.
So this is like its neck. And then we'll draw its face and its chin here. This is kind of like a mouth. Again, this is not necessarily how to draw a photorealistic cat, but how I would start with a cat. So
You're doing a great job.
give me some creative liberty here.
I think you're doing great.
We'll call this abstract expression.
Abstract.
Yeah, abstract cheeseburger cat.
Yes.
So its face is going to be a little warped.
It's
but-
cute. It's adorable. It's so.
So this is that's its back, and this will be its back end now.
What about its tail?
Yeah, we'll add its tail in just a little bit.
Okay.
Chad, I have a question. You don't always have to stay within those squares, do you?
Oh no, you can go
So-
way outside.
And so what do the squares represent then? What does that
So
square represent?
this is just trying to give you an idea of the dimensions of your
Center
drawing.
and...
Yeah.
Okay.
So all the V's are, so the lines are what we call axes. So these are lines that are saying, okay, this is the X plane and this is the Y plane. So when you're drawing, you know, okay, I'm working on the ZX plane or the ZY plane. And after you're done drawing, you can use those planes or axes to do revolves and things like that. Like the cup, I think some of you guys did. We can do another cup in a little bit to explain why the lines are important there. But these kind of give you an idea. When you're designing, you don't really necessarily have in mind the real life size of this because it's just on a computer screen.
Right.
Sometimes these squares are actually scaled to be like an inch by an inch to give you an idea of, okay, if I made this in the real world, this is how large it would be. Yeah.
So like at the bottom, if you go over to like the side. Oh.
So you can go outside the
And
square.
yeah, so you can go
Then it's at
way
negative.
outside,
It's at
and
negative
these
3.
points in the bottom corner here are actually the X and Y or Z and X or
X and Y.
yeah, those are the points like if you're graphing on a graph, so the X and Y points.
And then
are
if you go above it,
Cartesian
then it doesn't
coordinates.
have to
Yeah, so we're in the negative Z plane and then we go up to the positive Z plane and you see the number on the right change from negative to positive, and these are in inches, so I'm now 7 inches out and 0.46 inches above the Z axis. I'm going to redraw my cat because it looks ugly.
No, it's cute. Wait, what?
Why did you delete everything?
You undrew it.
You will be doing that a lot.
Yeah, so this is always a process. When you're designing a part at NASA, it usually doesn't have to look like a cat. But you do always go through lots of meetings where everyone sits down in a room and says, okay, this part needs to look different. And sometimes you'll spend like a week just working on one simple 2-inch by 4-inch part, which is a really long time for a very small part.
2-inch by 4-inch.
Wake up.
It's so small.
It's like dumb.
How long did you work there?
And also what we're going to do is you're going to first sketch out your avatar on paper so you have a sense of,
So this,
and then you'll do it in
How long did you work there?
so I worked there for a summer. It was about 3 months in Houston, Texas. It was really, really hot.
What? So weird.
I was 19. So this is like, it's like,
Wait, no, you're
You're
supposed
like,
to
oh
go
my
back
god,
anyway.
yes.
so the other thing to keep in mind here is that there are tools for helping you draw. This is a really tall cat.
It's okay.
There are tools for helping you draw what are called splines or arcs. So if you're doing like the back end of the cat and this needs to be a curve, see how I divided it into a bunch of little lines? We can actually go back through and make these look nicer by making them into a curve instead of a bunch of little lines. And really that's kind of a good process if you're making something that's complicated. You're going to want to design in straight lines and then use curves to make it look a little better. Yeah?
When you were doing the back, why did you do it like divided lines instead of just doing one straight line?
Because it was straight.
Because then it would have a flat butt. We want to give it some character to its butt. So we'll...
Chad,
yeah.
you know how cats kind of go like, so if I'm starting at the leg, they kind of go like, and then they go like, because all of these cats,
They kind of go like.
They arch their back.
yeah, because they're really,
Yeah.
really skinny.
Cats aren't skinny.
Yes, they are.
Yes, they are.
And they don't all cats.
They're like people, some are, some
They
aren't.
don't.
All right. So are you on the spline tool?
Yes, I think.
I think you have to make an intermediate point.
Okay, there we go now. I'll save my names. We could now do the same thing with a spline and put an arch in its back, or give it a little belly. It's got a really flat belly right now, so we can give it some tummy. Yeah.
You should probably use that thing from the leg, because the legs.
Yeah, so we could do all of that to make it look better. Again, what we want to demonstrate here is that we can go from a side view to something that looks a little more like a cat. So what I'm going to do now...
Can I ask you something?
Yeah.
How would you add a tail?
Yes, so you could add a tail here, just on the back, but I'm going to add a tail later to
Okay.
show how to add
Okay.
something to the back of
Okay,
it.
thank you.
So,
I think we have an open point right there. That's going to be weird,
Oh, yeah.
but it's just attached there.
Now he has weird tail.
Yeah, he's got a very small stub.
That's right, there's some like,
So do you see what he's doing?
Oh yeah, right there, right there. There's an open right there, and there's an open
Right here?
Yeah, and on the other point.
Oh yeah, it shows you. You see the red dots?
Yeah. So right here, right there, and right there. So this will just show us where we need to fix.
wow.
Oh,
These
yeah.
now will look more regular.
It's so hard to notice.
That was a
Yeah,
big
this one's
opening.
like so small.
There's the other one.
It's not playing very nice. So this is something the software I use. is a little better.
again.
All right, and then there was one
Right there.
over here.
That was
So
what?
You can delete lines.
yeah, there's a trim.
Yeah.
We can use trim, and it will just cut back to the corner. That will be
Oh, that
good.
was sweet.
Does anyone remember where the other one was?
Yes. Yes, go left.
No, it was up. It was at the top.
No, not up the top.
Let's take a look.
Yes, it was. It was at the
Oh, okay, we're good that time. So now what we're going to do is, much like our circles to cylinders, we're going to extrude this cat. Let's make it an inch. Okay, so now I'll show you one of my favorite tools.
All right, shh, be quiet. Hugo.
So as we just saw, adding curves in the two-dimensional sketch is a bit difficult. So what we're going to use now is the fillet tool, which allows us to add three-dimensional curves just by selecting an edge. So if we want to make these hard corners look a little better, we can actually add in this fillet. Too big of a radius. Let's see here. So what this basically does is turns a corner into a portion of a circle. It adds a curve to it.
So you're choosing the radius.
Yes, so this here is the radius that I'm selecting. Depending on how sharp your corner is, though, sometimes it won't let you do a fillet in that area if your radius is too large, because it will delete the entities that you're trying to fill.
And how do you think about like what size radius to put in there? They would probably be guessing, right?
Honestly, I click a shape and then I change radiuses until it's what I want it to look like.
So you're kind of guessing too.
Yeah, this is basically, so if you're designing like a box that needs to hold things,
Right.
if you do too much of a fillet, then your thickness in that corner might be so small that it's subject to breaking there. So like if you made a cup and you made a fillet at the bottom and there was only like a paper's worth of thickness there, it may not print very well because it's so thin in that area. But since this is all solid, we can basically fill it and we should be okay just about anywhere. Yeah.
So fillet is really rounding edges.
Exactly, yes. Yeah.
So, I don't wanna, so, yeah, okay. How would you make the cat skinnier? Because that makes
Yes.
Garfield like healthy and full.
Yeah, so what we can do here is we can make another sketch on the top of the cat, and we could take like a line through here. So let's use a spline again because the cat kind of has a curved shape to it. So we'll make a curve at the back of its head to give the head some width. Oh, I'm ellipse.
Wait, that's just a little.
Yes, this is the spline. Here we go. So let's. This is gonna look like a very.
Is that our cat?
It's the top of the cat, right?
Yeah, so we're looking down from the top of the cat right now. This may be a really skinny cat.
Yay! So the cheeseburger will be fatter.
Okay, so now we're gonna make this a closed shape. And we're gonna make this closed off as well. And we can now use this to like slice everything off of our cat. So we're gonna just slice all the fat off. Make a really skinny cat. So we deactivate. Oh no, we're not closed somewhere. Let's go back here.
I think I see it. It's right. I see it. It's in that the left.
Oh yeah, yeah.
corner.
It's in the
left corner.
Oh,
Let's see who was right.
It's in the left top.
Ooh.
yeah, it's in the left top.
It's in the bottom.
Left corner.
Sorry.
That's the right corner.
So you can actually click heal there and it will fix it for you.
But not every error has the heal option.
Yeah.
I've learned that.
So now we can do what is called a cut extrude. So we select cut extrude, and then we can basically say, let's see, this is probably taking a cut the wrong way. Let's see, what we actually want to do. So what we were, here I'll show you guys just size it. So what was happening there is if we try to extrude cut that, sorry. If we were to do what the software just wanted us to do, what would happen is that we'd basically cut a hole of that shape through our parts. That's not what we want. We wanted the total opposite of that. So what I'm going to do to sort of trick the software into making it do what I want it to do is let's look at it from the top again.
No, it's like,
Okay, so now we see it from the top. Shoot, my sketch keeps going away. Oh, there we are. So I'm going to edit this sketch, view it from the top again. Okay, and now let's make a box around this entire shape. And now we're going to close this shape off to our box. So take this guy, delete it, take this guy and delete it. So sometimes you have to get kind of creative to make things work the way you want them to. And this is where this gets fun.
well, I don't think that one's
So can I just, so Chad,
Yes.
so what, the first thing you did was just cut out the middle of the cat.
Yes.
Okay. And so then how did you come to the, how did you get to
SolidWorks has a feature that allows me to click a box and does the opposite of cutting a hole in things.
Right.
Basically what I'm trying to make now is like a cookie cutter, if you will. Something that we're like pressing down onto the shape and it's going to cut everything away. So that's where this happened.
Oh, I get it.
It's kind of a more complicated way of doing this, but since the software wasn't cooperating. Okay, so now we have this weird, funky shape that will work as our cookie cutter. We'll click extrude, and now you see we have these two shapes that are being slided through, and they're going to cut a hole on the two pieces that we don't want. And we can use this box to select how much we want to take away. We click OK, and now we have a thinner cat.
Wait,
What are the ears?
Opposite.
So the other thing you'll notice.
This is just stupidity, but how do you undo things in this? Can you undo it a few times?
Yeah, so you can do Control-Z and it will go back. The other thing you'll notice is it kind of looks like a moose now, so let's
Yeah,
call
exactly.
this will be a moose hamburger cat.
yes.
Did you hear what I just said? Because some of us, remember you were having a hard time undoing things?
So you
So
can
you
do
do, yeah, listen to chat.
Control and Z at the same time will undo a bunch of things. You'll notice that we can go back now and change that cookie cutter shape we used to take the ears as well. And actually what happened here is since we drew the sketch on its back and its ears were taller than its back, and we just cut everything down from its back, the ears were above that, so those didn't get cut. What we can go back and do is select this sketch again, do another extrude cut, but instead of going down, we can go up this time and catch the moose ears.
Oh yeah.
Antlers, that's the word I was looking for.
Did it just happen like a move?
So you know how like a cat has like 2 ears? Like if we do that, then the center is still gonna have
Yes,
that lump.
yeah, I'm going to get to that in just a second. That's the next thing we're going to do, yeah.
Can't you just press that little arrow right there to undo at the very top left?
Yeah.
Yes, you can also do that, and that will step back as well, yeah.
A bunch of times? We'll do a bunch of times.
So I usually find when I'm using a computer that it's quicker for me to do things on the keyboard than it is move the mouse across the screen, especially if I'm doing like lines and I don't want to move the mouse all the way across the screen and then back to the line like exactly. So I can use the keys faster than I can move the mouse.
Wouldn't it look cool to have giant moose ears?
No.
So since it's your design, you can do
Could we put like
really whatever you want.
All right, hold on.
the circles on the moose antlers?
Let's go back and edit this. Okay, so now it has no moose ears, and what I did there is a neat function that says instead of to depth, which is from down from the back, we can just do through all, and that takes everything. So now this cat only has 2 legs, it only has 1 ear. It's going to have some problems.
What about eyes?
So, yeah, it has no eyes. We could add eyes on later. So, how do we divide the ears and the legs? The answer is more cut extrudes. So we just make more sketches like we did from the top to make it skinnier, in between the ears and the legs to divide them up.
Yeah, how would you do that? Because then wouldn't it cut through the whole thing and make like it looked like ears?
You're right on track. You are taking me to my next point. So what we want to do is select this unit ear. We just selected the front of it, and then we're going to tell the software we want to make a drawing on top of that ear. So we can now make a sketch, and then all we have to do is draw what we don't want anymore. So if I want to take away a section from, so that would be its left ear, and its right ear. Connect this shape all together, and then we click deactivate sketch, and now, you guessed it, we cut extrude. And what you were asking is basically, we can adjust how far this will go through.
Because then it might
by-
go through its like neck or something.
Yeah, so we don't want it to go through its neck, so we can adjust how far it goes through. And you'll see over here it's dragging a plane that's showing what we're cutting away. You'll also notice that it doesn't do us any good cutting this way, so we're going to reverse that. Right now its ear would go all the way through it. That's not going to be very productive. So we will drag this back to where we want it to
But
cut.
wouldn't that be facing that way?
Or the other neat thing you can do, let's get a better view of this. So now actually what we can do is do this cut extrude, and it should have a feature that says to next. So basically we select this sketch again, and then we tell it, okay, we want you to extrude back to the next plane, which may be too far, but let's see. Sometimes this works, other times it doesn't. That one didn't work, we just put a hole through everything.
But you can't really notice.
Yeah.
Notice it when you
Oh yeah, when you face it. No, let's do it.
It's gonna look funny.
Then you can have water going through.
Oh yeah, water going through it.
That's the other thing is, Kyle, do you know how to easily revolve with the mouse in this? Or?
Hold down
Oh,
both the
you hold
mouse
both of
buttons.
them.
Oh, okay, cool. That makes life so much easier. Okay, so now we have a better view. In SolidWorks, it's just the middle button, and I've been trying to figure that out. So we'll select this sketch again, go back over here, and then let's do to geometry, maybe able to. Okay, so there we were able to select the back, click OK, and it just takes out that shape. We have exactly 2 ears now.
We have two legs.
What option did you choose? To geometry?
To geometry, and then I selected the back plane, and then it worked. To make these look more like ears, one moment, we can add fillets in. So if we select here and here, that's way too large.
What are you doing?
Too large. The software does not like me. Okay, yeah.
So with the legs, are you gonna cut it sideways?
So I'm
Or you
going
can make
to
a box and then
Like
like
what you
this?
see.
cut from the front like a rectangle through the center.
Yeah.
Yeah.
But I think too, it's like that's like,
Oh yeah,
like it's like normal size and then it's like really thin.
Yeah. So that's because of the way we cut down from the top. We can make them larger at the bottom if we wanted to. I'm trying to figure out why this is not really in the way I want it to. Okay, so this one actually
the
Oh,
filled.
legs. We could save time. Like we need a couple legs.
Oh, did you just fillet the legs?
I did.
That was so cool.
So you have to be very careful to actually select the edge, and it will tell you when you've got an edge selected. And it will give you see these two curves here and here? It will give you an idea of what it's going to look like. So if I add a curve in here, you can see it's now sort of rounded there, which looks a little more natural than the rough edges.
Looks
So
like a dog.
let's add some more curves into its face to make it look a little better. So as you can see here,
Sixth grade.
you can sort of go from edge to edge, changing how much you want to fill it. We can click this more and more to get a better idea. So this is pretty extreme. Let's see what happens when we do this. Doesn't like it. That was too much. So let's try half of this, which is 0.06. See what happens now.
That's
its face and end up with something
Its
very
legs are
similar.
kind of too big for its body.
Yeah.
How about the other?
Do you have any
The legs need to go, like, the legs need to be short. The legs need to be short.
We need to cut the legs.
So this is looking like a very future curvy cat. Future cat, yeah, cat.
Except part of its nose is like this one. Part of its nose is like that.
Yeah. So
All right,
now
sixth grade.
we'll cut the legs in the center, which is great because everyone has said all we need to do now is put a rectangle there, and then we can cut. The legs look thinner because normally we expect them to be wider. We could make them wider by doing basically the same thing that we've been doing by taking away, but you can use the same methodology to make things larger. So like if we click on the side of a cat and say activate 2D sketch on this plane, which it does not like, we can now make a shape that is the size of the legs, just roughly by tracing. You can actually use a function that will abstract a shape to the plane that you're working on now, which is this tool. So we could just duplicate the cat shape and then take away the top lines, but that's kind of about as much work as what we're going to be doing by just drawing the legs again. So we'll draw the legs again, or at least just this one. This isn't going to be exact, but it's easy enough to do if you wanted to make it exact.
So one takeaway that I think we should all take away is if Chad is doing a lot of things by trial and error, then you know that we will be.
So
even more.
if you're designing something that is like a screw or a bolt or a bracket, something very simple, like if I wanted to make a box to hold pins or a cup or something like that, that you know what size you want it to be ahead of time, like I want a cup that's 3 inches at the top and 2 inches at the bottom and 4 inches tall, then you can go into the software and do that in like 10 or 15 minutes and you know all the sizes, so you don't really have to do any guesswork. But if you're doing something like a cat and you just have a vague image in your mind, you kind of have to, like, almost like if you're sculpting with clay, you have to go in small increments and make approximate changes as you go until you just get something that you like. Since this is basically entirely up to you doing something that you think looks neat, you can afford to guess and look at it more of like a artsy way than like an engineering way. But if we were going to be doing a part for a robot, we already know all the sizes or dimensions ahead of time. We just basically put those into the computer and get our shape out. So now that we've made that sketch, we'll deactivate it and we can just extrude again. Ideally, we want to do this on both sides. So again, we can do through all. Or start in the middle of the plane, and then this will give us a mount. Oh, shoot. Sketch. We can do from the middle of the plane, and this will give us an equal amount of leg expansion at both sides. Or should have. Oh no, because it's done on the middle of the plane. So instead of that, let's just do to depth, and then we can do it on both sides.
What is to geometry?
So to geometry means that you can like select an edge or a face, and it will go to that face. So like if I clicked on cat body, it would go down exactly to that point. So if we click OK here, it's going to be mad at me because... But basically, you can click on sides, make sketches, and then extrude up and make them thicker. Like for instance, if you wanted to do a tail, we'll click this back, activate a sketch on it. It's non-planar. Let's look at this plane. So now we have a nice view of its rear end. And what I'm actually going to do here is just draw a circle. hopefully, maybe somewhere. Deactivate, and now we can extrude.
Wow, this is what?
So very straight tail.
It looks pretty good.
What you could also do here is a neat feature called sweep. So for instance, if we drew a line from, let's activate sketch.
Why can't we make the 4 marks?
Oh, we can, sorry, I got distracted by trying to make an awesome tail. We'll go back to 4 legs in just a second.
It was supposed to make the hamburger onto the.
Why don't we just make it at
So now that we have this line,
really cool,
so since this is not really needing to be a closed sketch, that's fine. So now we can take, hopefully, this circle that we drew, or not because it's not in the right place now. Let's delete that. Let's go back around to the back, and we want to draw a circle at the base of this. Make sure I'm doing this sketch to sweep. Okay.
What is sweet boss?
So basically what we're going to do is we're going to draw a circle at the base of this line, and then sweep will drag that circle all down that line to make a curved cylinder, which is going to look really nice.
Real.
Let's draw a circle again, okay? Deactivate. Now we should be able to tell it, okay, we want that circle to go along this path. Okay.
No.
Now it has a back tail.
No, it's 7.
So all on the sidebar, Chad, that's like layers in Photoshop.
Yeah.
You know.
So these are showing us all the steps that we've done.
Everyone see that on the sidebar? You can click on wherever you want to go.
And this will show you the things that you've done and where they are, and you can go in and edit.
And select them.
So now let's give it 4 legs. It deserves 4 legs. It's had a hard day.
Tail.
So cool. Oh, look, he has a smile. He has a smile.
Okay. So let's go back to our old extrude cut routine.
So be quiet so we can see how to do this.
Again, we can do 2 geometry and just select the back half here, and it will go exactly through to that back. So that's what 2 drop. Did everyone see that? So 2 geometry. Let's go back to 2 depth to show the difference. 2 geometry. If we go back, we see here the red lines on the front of the legs are our sketch. We go to the back of the legs. We can select where we want it to extrude to or to cut to, which is this back piece. We click that, and now it's showing that it's going to cut back to that shape. So we click OK, and now it didn't extrude far enough. So let's redefine our geometry to something that's a little further back. Select the sketch again.
What's the difference between that extra? See, like, it says revolve there, and it says revolve there, and it says helix there, and helix there. It says
Helix?
like, what's the
Add
difference?
and cut.
Yes, so yeah, one of them is adding material on, the other is taking material away. Do you have a question?
Yeah. Why couldn't you just do the add geometry to the other back leg?
Yeah.
Do both of them at the same time.
Because they're at different angles, so I wanted to do maybe something that would look.
Press down and let it do the whole.
So now it almost has 2 legs on the front. Let's do this trick that I did earlier, through all sketch. Let's select this sketch. So this will give you an idea of what would happen if you did that, which is decent. If we're happy with that, I'm happy with that. What we can also do is we can select this back plane and make another sketch and just do the rest of what we need there. So we'll select from here to here.
It's a bit like the Trojan horse.
So cut again.
70 out.
First, go that way. So now it has 4 legs. It's alright, it's alright. We can fix that. We are cat surgeon specialists here, so it's alright.
Are we just making a cat so it's like surgery?
Wait, can we please print this?
Please.
Yes.
Yes. I won't. It'll take forever to print.
No.
Oh, well, it'll take like 10 minutes.
Okay, let's
I mean, you
fix
won't be able to
that.
see it today.
Deactivate the sketch. Let's try to cut this again.
Come on.
Okay, alright. 4 legs. I think.
Surgery success.
But that
Surgery
like
was a beautiful success. We can we can go back in now and add some more fillets.
That's where we're leaving? What?
It's the new hip style. It's the back tail.
Hey, if you all want a moment to stand up in your spot and stretch in your spot.
Cool. That's not what you call it.
Free, but it's
You
free.
can jump up and down.
But I got it for free.
I'm proud of you.
From my uncle.
I'm proud of you, man.
All right, get your stretches in.
Dude, but how long do you
Yes. Okay. What,
All right.
How much time do we have left?
We have a half hour, but you can take more.
Okay.
All right. So would you all sit down now?
drifting away? Way back away.
You go.
This is going to be entertaining.
All right. 6th grade. Let's go. Have your minds back on the board and chat, please.
So I'm just adding some curves to the legs to maybe make them look a little bit better. Again, we're just going through and filleting. This is something that you can take as much or as little time as you like doing. I kind of like adding filleting. One of my mentors once told me that, you know, if you're going to use a machine like a 3D printer that can do all sorts of really, really nice curves, why not do all sorts of really nice curves? So we like to show off the fact that we can do nice curves because 3D printers do nice curves. So adding in a lot of fillets is acceptable because the 3D printer is basically made to do that. So that's why I'm just going through and adding a lot of fillets in. Always fillet. And it does look better. Yeah. Yeah, what were you had your hand up? Okay. So just to make his paws a little more curved. All right. So let's put a cheeseburger on top of it.
Oh, that could be straw and cheese.
Yeah. I'm also going to try and make its body curved. Oh, perfect. Now its chest has a little bit of curvature. So this is again the beauty of fillets. It's curved now. Looks a little more cat-like.
I think it looks like a cat.
Let's give it the neck.
Oh, yeah.
Oh my god.
Gosh.
That's so awesome.
We should make it have hair now.
Oh, it's messed up. You do that? Oh, it's
Jack, can we make it have hair on it?
You could. You can add textures in SolidWorks, which is crazy, but. So let's try and give it curves up top as well.
There's a whole, no, I'm serious, no.
Yeah, what's up?
And with SolidWorks, do you have to have like a certain kind of 3D printer?
You can basically use whatever you want, which is nice. You can export everything to a similar file type, and then just 3D print from that file type.
So like you can export something from SolidWorks to Cubify, then print it without changing it?
Yeah. So basically, most of the 3D printers that we use are use a file type called STL, which is basically it takes your shape and breaks it into a bunch of triangles, and any 3D printer can work from that file type. So they all have a similar file that most softwares can export. So now with the curves, it looks even more like a space cat.
Future cat.
Maybe that's what we call it. Cat of the future.
Robocat.
Yeah.
Shadowrun.
Aerodynamic.
Doctor Who has canine, this is feline.
Yeah. So again, you can add fillets wherever you want. Fillets everywhere.
Can you please change the tail?
We can fix its tail first.
Just make it so that the tail is going up and then goes back.
So let's
How Liv, can you change the size of that so when you print it, it's like huge or something?
yes. So you can scale it with the 3D printer software to whatever size you want.
How big will it be?
Oh, and do you know anything about a 3D ruler?
Yes.
Like what? Like what are some like advantages to that? Like what
So,
do you use that for?
We have one. The nice thing about it is that if you have something that's 3D printed, you can use the doodler to like draw on 3D printed shape. Using the 3D doodler to make like a cup or something like that is kind of complicated, but you can like draw your name or initials or whatever you want onto a 3D printed part. It makes it really easy to do that.
And add color. You could add color with the 3D.
Oh yeah, yep, that as well. So to fix the tail, the sweeps are a little complicated because what we need to do is put the line right in the middle of the shape. So what I'm going to do now is kind of complicated, but we'll figure it out as we go. What we need to do is put a plane in the middle of the shape. So what I'm going to do now is, you can see this square of black lines that's coming through the shape now. This is a new plane, which is a flat surface to draw on. Actually, what I need to have is a plane right on its back end that I can draw on.
So say again what a plane is? A plane is a surface you can draw
A
on.
flat surface that you can draw on, like a virtual piece of paper. And wherever that plane is in your part is where your drawing is going to be. So drawing a tail in the middle of the body is going to make a tail starting in the middle of the body. And it's a little easier to make a tail on the back than it is in the middle of the body. So you can select the planes it gives you. When you start out, it gives you an X, a Y, and a Z plane. This plane just happens to be in the same orientation as where its back end is, so we'll use this plane to draw our new sketch. I'm also going to try and hide some of these things so we can, let's see. Oh, no, that's not what I wanted to do. So that was just, you can tell it to pretend like you didn't do things. That's called suppress. And when you tell it that, it reverts to as if you hadn't done it before. In SolidWorks, you can actually hide features so they don't, all the lines don't crowd your drawing, but it's all right. We'll just deal with it. So now you'll see the black lines. That's the new plane that I have, and we can make this plane wherever we want it. Also, sometimes you can actually select geometry and align the plane to that. That's kind of also a more advanced feature, but here we can kind of guesstimate just by looking at it. So we'll do let's do 0.05 and see where that puts us. So if we look at it from the side now, that's basically right. We'll do its tail right here, and we should be okay. So now I'm also going to put a point here. Going to make another plane that's in the center, and then we'll put a point where they interact. So let's look at the shape like this. So now we can put a point on this plane and this plane. One right here.
And why do you have to create other planes?
So basically, when we're trying to draw this line,
Yeah.
we want to make sure we know exactly where it is. Which in this case, it needs to be in the middle of this shape. In the case of the first line that I drew, it was all the way back here, which is what made it freak out when you put it on the top of the shape instead of the back. So now we'll try to draw this line again by making a sketch, and now we'll just make that spline over again. We're going to try and make it right here where this plane comes out, and that will put the circle, and that's where we'll put the circle to drag along the tail. So now we'll make our tail shape. Let's go with something like that again.
Couldn't you just use the whatever you call it thing and then make it like
The sweep?
Yeah.
Yeah, that's what we're going to do. To do a sweep, you have to define the shape that you want to sweep. So in this case, we want to just do a circle because we're doing a tail, which is circular. But you will also have to show it the shape you want to sweep the shape across. So this line is what we're going to drag the circle across to make the tail. So the second line is the old one that was drawn on the back plane. So we'll go in and delete that because we don't need it now. We'll ignore the fact that our sketch is not closed. We now see, okay, so this sketch 6 is that line back there. Since we don't need it, we'll just erase it, and now it's gone. So since we've got our line drawn for where we want our circle to be swept across, we can draw the circle and then sweep. Yeah. Okay, I see. Cool beans. So let's use this plane that we drew on the back of the cat. We'll click Activate 3D Sketch. And what we want to do is draw a circle right on the center point of where the line goes into the back of the cat. So we'll zoom in, we'll click on that in point, and let's make its tail 1/8 of an inch in diameter, which looks like it's going to be radically out of proportion with the rest of the cat, but this cat's not really in proportion anyways, so just go with it. So now, since we're out of our 3D sketch, we can do our sweep. So we click the sweep tool, we tell it that we want to sweep this circle that we just drew, and then now we click the path that we want to sweep it across. We cross our fingers, we press OK, and now we don't have a back tail, we have a back end tail, which looks more like a cat tail. Again, we'll go back to our favorite tool, the fillet, and we'll make the transition look a little better between the back of the cat and where the tail actually starts. So we'll select this edge, click OK, and that sort of makes it look a little more natural. What we can also do is go up to the top and actually fillet the top edge of the tail and sort of make it pointy. We're going to need a little more point than that, but So we can go back and edit that fillet. Let's make this like a...
That's not too bad.
That's
A little
good.
bit big.
Let's do a .06, 16th of an inch. Too large still. 0.04. Oh, that's huge.
How does it know that it's too large?
So basically when you're filleting and your curves are like crossing and canceling the geometries of our cylinder out, that's when the fillet is too large. So you can actually do the math in your head to determine what is too much or what isn't. But essentially to approximate, since this cylinder is 1/8 of an inch in diameter, if we're doing a radius that is 1/16 of an inch in diameter, those will cross out. So you want something just a little bit smaller than half of whatever your radius is.
Can I ask you another question
Yeah,
about
go for
fillet? So when you do fillet, you just click on the edge.
So you can click on the edge, or you can click on two planes, and it will average the planes together. But that's usually a little more particular about what it's doing in terms of constraints. So it's more picky about what it will let you do if you're doing two planes versus one edge.
So
like,
for us, really choosing the edge is what we want to do.
it's pretty easy.
Okay.
Fillets will do some really fancy stuff if you start doing planes, but like for instance, if we're going to do this edge, it will actually continue up the entire
So
edge. which
will
is
it make
nice.
like the back of the leg like curved like this?
Yeah, which would be nice to do, but it's being really particular about how it wants me to do it. So let's play its game for a second and see if we can actually make this work. So it's probably not liking this curve here is actually the problem.
Because you made it like skinnier.
Yeah, this one on the other hand, got a little hopeful there, and let's see if we can do this instead. So as you'll see, if I start clicking planes, it gets really complicated really fast. All right, let's give up on that. Wow. So Space Cat, it's pretty cool. Cheeseburger. Alright, sorry, you've been outvoted on the cheeseburger. Okay, so now that we have Space Cat, this is basically an example of how to go from a 2D sketch to something that kind of looks maybe like a cat on a good day. To show you a couple of other neat techniques that you can use to make things, let's save Space Cat, and then we're going to do like a cup, and we're going to do a weird twisted flower
Can I ask
vase.
you one question about the cat?
Yeah.
For like eyes, should we just do that with decorations?
So you can also add eyes in, basically the same way we kind of did the tail. You just go into its face, click on wherever you want to add an eye, and then you can add a circle and extrude and then fillet it to make it look like a hemisphere.
Okay.
Or at least that's how I would do it. You could also go in and cut extrude if you wanted to make a recess for an eye and add a direct. Or you could add googly eyes and make it look even more derpy, which would just be adorable. Okay, so now that we've saved it, let's make a simple cup.
But are we gonna be able to print that at the end of the class?
Yes, we're going to print it.
Yeah, so we'll print.
It could be the classroom cat.
Yeah.
Yes, exactly.
Class mascot. So much like we did sweep,
Alright, 6th grade.
we're gonna use a feature called revolve now, which you can basically take like a shape and then revolve it. And if you've done the wine glass, you did the same this procedure. Yeah.
What is boss? Like add material boss. What does that mean?
So what that means is that so boss is adding. It's additive. So if you have a let me illustrate by doing the part. I didn't do a good job about explaining that. So that was freaky. Let's draw our shape. So what we're doing here is drawing, again, a two-dimensional cross-section. Like if you're looking at a cup from the side, what would that sketch be? Yeah.
Wouldn't you make it, I forgot what it was called, how you made the tail, the line?
Yeah.
But wouldn't
Sweet.
you do that to make it curve?
I'm sorry?
To make the side of the cup curve?
So you could kind of do that. The problem is that the cup needs to be closed on the bottom. So if you were to do a sweep, you could do like the curve of a cup, but you would have like a shape kind of like our tail that, so you'd have a curve like this, right? But you wouldn't have anything here, and you wouldn't have anything on the other side either, and it wouldn't be an entire, like a conical shape, a cone. So what we're going to do here, you can make your curve in 2 dimensions. So like for instance, let's say we want our cup to be 2 inches wide. So we'll tell it this cross section will be 1 inches, and when we double that, that'll be 2 inches. And let's say we want it to be 3 inches at the top. So we'll make this top line to be 1.5 inches. Make this dimension to be 1.5. And now we can add in a spline to make some sort of funky shape.
What does spline actually mean? Is it a mathematical
Something
term?
line?
Yeah, it's,
The SP stands for something.
yes it does. Wikipedia.
A rectangular key.
Okay, so now these splines do not like that. Okay, so now we have our spline. So this will be our outside shape of the cup, right? Now we'll get into that boss thing we were talking about earlier. Let's look at where this opens.
That's a really cool cup.
Yeah, it opens somewhere.
Right there.
Oh, thank you. Good spot. Let's close this.
Oh yeah, can't feel it because that.
And are you zooming in just using the keyboard?
I'm sorry?
Are you just zooming in with
Oh, I'm using the scroll
mouse.
wheel on the mouse. So deactivate. Oh no, it's still open somewhere. Oh, wait. That's not what I meant to do. Unsuppress, edit. Deactivate. Where is open? Please show me.
Oh, it's still the same place. Oh yeah, because you deactivated it. What? That doesn't make sense.
Oh, I see that one.
Sometimes you have to get.
You can't even see it when you're like this.
Just give me 1 second.
Oh
Oh, you deleted the whole bottom.
no! Alright, let's put. It's alright, it's alright. Let's zoom in to make sure we actually. Oh. So click there. Alright. Click here and click here. You know what? I'm just going to do a line. Alright. So now we have our line drawn. We'll deactivate. It's closed. Okay. So what Boss will do is it will take this sketch and add material. So we go from our sketch, which is basically nothing in 3 dimensions, and it is taking that 2 dimensions and adding material to it. What the cut means is that you can have material, like for instance, let's say we wanted to make a screw pattern on the outside of our cup. We could take that material away from the cup that we already have, if we already had a solid cup, by using the cut helix. I can show that once we have our cup. Yeah.
Is there any possible way to, like, for instance, for the revolve, could you actually like draw around it and make it revolve with that?
Yeah, exactly.
Or would it be like you say okay and it would do itself?
We draw a circle and then show it the surface that we want it to revolve around, and then the computer does all of that for us. So what you have to do is tell it the sketch that you want it to revolve, and then you show it the center line of the sketch, which is this line. Then you click, axis. Click this axis. It's not happy with the axis that I'm on. Alright, there we go.
Whoa, gee, that's pretty cool.
So here's our cup. as always, we'll add some fillets because why not?
Are we gonna print that and make it? I can copy it.
I don't think they're. Drink out of printed cups.
You can. If you're just drinking water, if you're drinking fluids that will not degrade the plastic, like water,
Lemonade.
it's fine. Acidic beverages will degrade the plastic.
Or hot water.
Or hot water, or hot chocolate, or coffee, because it's got some acid in it as well.
So
Yeah.
then so you know how the 3D printer makes like texture so that it doesn't fall over or anything? Would it make like stuff inside
Oh,
the cup?
support material?
Inside the cup?
It shouldn't, because the angles that we're printing at are not big enough to need support material. Another neat feature, yeah, go for it.
So like the stuff like that green, like blue stuff in it right now that like.
Yes, the
Yeah.
ABS filament.
Can you like change
Oh,
that
peel it, nice.
into like all sorts of different things? Like, could you put like this like metal ABS filling?
So, this printer can only do like different types of plastics. To do metal, you have to use a different type of printer. So these printers, to get into the 3D printing section of the talk, I guess, what this is called is FDM printing, which means fused deposition machining, or modeling. And basically what that means is that you are putting layers together, you are fusing layers of plastic together by depositing new plastic. So FDM machines like this 3D printer and just about every other consumer grade 3D printer that's cheap enough for you and I to buy and put in a classroom or our homes or anything like that is going to be taking plastic, melting it like a hot glue gun would, and then just melting more and more plastic on top of it.
And then it sticks.
And then it sticks together, yes.
What's like the most expensive 3D printer?
So that would be metal 3D printers. What was your next question?
Yeah, I was just like, you can use metal.
So the way metal 3D printers work is pretty crazy. They use really high-powered lasers, which are awesome. Lasers are always awesome.
They use metal powder. They use metal
Wait,
powder.
let him finish his
Exactly. So you have this like a sandbox that you sweep metal powder into. So you take this really, really fine metal powder, which is more finely ground than sand, usually titanium oxide, so it's a type of titanium. And you have this like paddle at the side of the printer that goes through a big pile of the powder and takes the paddle and sweeps it across the box on the inside of the printer. This is kind of hard to picture. Let me see if I can pull up a picture.
How much do they cost?
Lots of money. Hundreds of thousands of dollars.